Alrighty, here's 3-3. Long division and synthetic division is what we are after. Two different methods of kind of doing the same thing. We're dividing polynomials. I want to show you long division first. That'll be kind of the first half of the lesson. And then we'll get into synthetic division. The big picture is we're dividing two polynomials. Okay, this is kind of how the algebra works to do that. The other piece, though, is we're looking at how to find zeros. Okay, that's the other piece. All right, if in light of not being able to factor in a certain situation, that's kind of what this is after. Is if we have higher degree polynomials, really tough to factor. How do we find zeros? Really, we're kind of building our way towards synthetic division. That's going to be the biggest tool that we have that's going to help us do that. And we'll kind of work our way towards that today. In 3-4, we'll really get going with that. Okay. This one's kind of related to finding zeros. Okay, but here's what's going on is I can see for this third degree polynomial that x minus 2, I believe, is a factor because x equals 2 appears to be a 0. Okay. If I were to divide out that factor, there is some second degree polynomial, in other words, a quadratic, that's what's left over after I take that factor out. Okay? Now, here's how you do that. We'll take the factor, and we'll divide this original third degree polynomial okay? So I'm taking that cubic, dividing it by x minus 2, okay? The first thing I need to do, and it's basically like a sequence of rounds of division that repeat each other. I'm going to subtract these two terms, but what I have to do is put a term up top so that when I multiply it by x, I get 6x to the third. That would be 6x squared, okay? Now I also got to multiply the 6x squared by the negative 2 to get negative 12x squared, right? I got to multiply the term I picked up on the top by both. I don't care if the second term doesn't cancel. That's the one I was trying to cancel, okay? All right, negative 19 minus negative 12 is negative 7. And then I'm going to bring down the 16. And once I've brought that term down, I get to a point where I'm going to do another round of division. Okay? And we go back and repeat the same process. Except now I got to pick a term. And I shouldn't say pick. I really need to figure out what needs to go there. A term that when I multiply it by x, I need these to cancel, so I have to get negative 7x squared. Negative 7x, right, is the term I'm looking for. Notice how I'm keeping everything lined up, right? X to the thirds got lined up with x to the thirds. X squareds are lined up with x squareds. X to the first and constants, right? Everything has got to stay in its kind of appropriate column. Negative 7x times negative 2 is positive 14. Those cancel. 2x, right? I bring down the constant, right? My last term. That means this is my third and final round of division. Once I pick the term to go up top, multiply it down and subtract, this round's over. This problem's over. Okay, we will have done the division. Okay? The term I need to put up top is plus 2. Because 2 times x is 2x. That's what I was looking for. Now this problem doesn't have a remainder. You'll see both today. Some that do have remainders. Check this out. Cancel, cancel. No remainder. All right, so this q of x, this kind of mystery polynomial. In fact, I'm going to write it this way. I'm going to go back and just write f. Because here's kind of how we were originally thinking about the problem. Right, we took out the factor of x minus 2 because it had a 0 at 2. That second degree polynomial that was left, 6x squared minus 7x plus 2. Okay? Because here's the thing. If you wanted to find these two other zeros that look to be a little bit trickier to find, the two zeros of that quadratic would lead you to those two zeros. Okay? That's where you'd find them. Okay? Which is a good thing because we've seen before, finding the two zeros of a quadratic is a lot different situation. They're usually a lot easier to factor, and you've got the quadratic formula. All right, let's do another one. Okay, the process is always the same on long division. I'm going to show you two more, and then we'll move on to synthetic division. Each of these have a little wrinkle that I want you to see. For example, we're doing x to the third divided by, or x to the third minus 1 divided by x minus 1. There's no x squared term, but when I'm dividing, I got to write one. The x squared term has a coefficient of 0, which is why it doesn't show up, but write it in. Right? We have to keep everything perfectly lined up with the terms that are the same. Okay? So here we go again. What term do I need to put up top so that when I multiply it by x, I get x to the third? That would be x squared, okay? Make sure it lines up with the x squareds, because then I multiply it by negative 1 as well, and I get that, cancel, positive x squared, bring down 0x, okay? And now we're ready to do another round. Whatever term I pick up top, when I multiply it by x, I have to get x squared. And that's easy enough. It's just x times negative 1 would be negative x. And just like last time, this is going to take 3 rounds. I know this is my last round of division because I brought down the constant. I need a plus 1 up here because 1 times x is x. 1 times negative 1 is negative 1. And look at that, it's another one with no remainder. Okay, the next one that we do here will have one. You'd get x squared plus x plus 1 if you divided those two polynomials. All right, this one will have a couple little pieces that are different. Starting with my divisor is going to have 3 terms. That's okay. Doesn't change anything about how we do this. I'm going to get the terms in order. That's really important to do. Same thing here. I need 2x to the fourth plus 4x to the third minus 5x squared plus 3x minus 2. I need a 2x to the fourth to go right there because I need those two terms to cancel. What do I need to put up top? Keeping in mind the first term that it's going to get multiplied by is x squared. So in my x squared column, I'd have to put a 2x squared. 2x squared times 2x is plus 4x to the third. And 2x squared times negative 3 would be minus 6x squared. Now we get kind of a bonus, right? We knew that first term was going to cancel out, but guess what? So does the second one. All right, so then I add those together, right? The negative 5 plus, minus negative 6, which is really a plus. And then I'll bring down the minus 2, okay? Now this is actually going to be my last round, and I'm only going to do 2 because those 2 terms canceled out, okay? But the other thing that this tells me is I've brought down my last term, so this is only going to have 2 rounds, okay? I need an x squared right here, and to get it, I need a plus 1. One times x squared, 1 times 2x, 1 times negative 3, right? All right, we'll cancel there. I knew that would happen. All right, so watch what happens here. On the last 2, we had remainders of 0. 3 minus 2, 3x minus 2x is just x, and negative 2 minus negative 3 is positive 1. All right, so here's what we're looking at. Q of x, which is our quotient, was 2x squared plus 1 plus, here's our remainder, and that always goes over our divisor, x squared plus 2x minus 3, okay? So there's another one, all right, but that one does have a remainder, and that's how you handle that whole remainder situation. Okay, synthetic. We actually had a couple cases we could have used it. It's when your divisor is in the form of x minus a, okay? If x minus a is your factor, then what you divide by is x equal to a. That can get a little bit tricky right here, because notice it's x minus a. So if you had this factor of x plus 3 that you're checking, you have to think about it like this. It's really x minus negative 3. So when I use synthetic division for this problem, I'm going to use negative 3. Okay, and I'm going to try to take it one slide at a time. There's a bunch of stuff that you're checking here when you do this. Okay? For now, just think of it like we're doing the same process. We're taking this fourth degree polynomial and we're dividing it by this smaller one. Okay? But also think back to the first slide that there's a couple other things that we're checking. Okay? Again, this is really more what the next slide is about, but I'll tap into it here. If we get a particular result, we could notice that x plus 1 is a factor and that x equals negative 3 is a 0. We'll talk more about that after we do the process here. All right, when you're doing synthetic division, you only need coefficients. Okay, you only need coefficients. All right, so here's how it works. Bring down the 1, then you take negative 3 times negative 1, and we get negative 3, okay? And now we do addition, right? 0 plus negative 3 is negative 3. Negative 3 times negative 3 is 9, right? This is where synthetic is a little bit different, is as we work vertically here, we're adding, right? We're adding stuff together. Here we get a negative 1. Negative 3 times negative 1 is positive 3, right? And again, keep in mind as we're working vertically, I'm adding, right? That's, again, probably worth kind of slowing down here to emphasize. As we go through this with synthetic, right? It's a stark contrast from long division, whereas you're working with the terms vertically. In long division, you subtract. Here we add, okay? We're kind of getting to the same result, but it's a little bit of a different method of doing it, okay? It's a little different method of doing it. Negative 3 plus 1, excuse me, negative 2 plus 3 is 1. Negative 3 times 1 is negative 3. And there we go. Okay? This right here would be like our remainder, because here's what happens. We get our quotient. It was fourth degree, okay? Now it's third, okay? Was fourth is now third, right? Because remember, to do synthetic division, it's probably worth another reminder, you can't always do this, right? Your divisor, that term right out here, has to be x minus 1, okay? It has to be in that form. Like the problem on the slide before where we were dividing by a quadratic, can't do it, okay? You'd have to use the method of long division. All right, so it reduces it by 1. It would be x squared, excuse me, x to the third minus 3x squared minus x plus 1 plus 1 over x plus 1, right? Because we had a remainder, we put it over our divisor, and there we go. Okay, let's try it again. It's similar with long division. You're going to find that in the homework too. The steps aren't impossible. They do require repetition. To get good at these, you just have to do a lot of them. Okay? All right, so x minus 2 means I will do synthetic division with 2, right? 6, negative 19, 16, and 4. Bring down the 6, okay? 2 times 6 is 12, right? And again, addition here. Add once they're lined up vertically, add them. Negative 7. Times 2, we get negative 14. Add them and get positive 2, 4, and 8, right? So here would be our quotient. We started with a cubic, so we're now down to a quadratic. We'd have 6x squared minus 7x plus 2. Remainder, we'd have 8 over x minus 2, right? Plus 8 over x minus 2. Okay, now let's look at these both a little bit closer on the, whoops. My writing doesn't want to move. See if I can adjust some. Whoops. I am not sure what's happening here. Usually when I slide up, the writing goes with it, but right now, let's see here. I cannot get it to move. All right, so weird thing I'm going to do here. I'm not really sure why it's doing this, but it is. So we'll make do. I need to scroll down to see the next slide, but then I think I need to erase this, right? Because for whatever reason right now, the all this writing here doing the long division, it's not going to go away, right? And as you can see, as we move to the next problem, we need it to go away. So let's do that. Here's the big. Sorry about that. Not sure what is going on. Typically, it just moves with the screen. But that's okay. Again, obviously shouldn't be a huge deal that if you needed to go back and miss anything, you could find the time when those notes were there and then just pause it there. Hopefully you got all of it though. Okay. Good enough, right? Okay, sorry about that. Couple questions to answer. Is x plus 3 a factor of that fourth degree polynomial? Okay, this is what I was talking about earlier. No, it's not. Okay? When we did it, r was 1, right? R has to be 0. That's what you're looking for, okay? Because I'm specifically talking about, x plus 3, right? So that means I'm talking about the case when I did synthetic division with negative 3. So let's kind of recap what we're talking about here. If I do the synthetic division with negative 3 and I get 0, that means negative 3 is a 0. And it would have meant that x plus 3 is a factor. Didn't happen, right? Did not happen, all right? Over on this next one, was x minus 2 a factor of that third degree polynomial? No. R wasn't 0, R was 8. Okay, again, to kind of recap what that means, x minus 2 is not a factor. X equals 2 is not a 0. Okay, in fact, it even tells you a little bit more than that. Not only is 2 not a 0, right? Because if it was, it means I plug it into this and I get 0. If you were to plug it in there, I can tell you, you would get 8, right? Not 0. Okay, that's kind of weird. I did 2 of them. I probably should have picked one to show you what goes on when it is a 0, but oh well, I didn't. Not a big deal, but if you did get a remainder of 0, the number you did synthetic division with is a 0, and you're talking about a factor. Okay, so here it kind of tells me, doing repeated division. I kind of want to show you how that works. It doesn't do anything different, but it's got a little twist to it that you should know, right? Because here you're going to see the whole factor and a 0 thing show up. So right off the bat, x minus 2. I'm going to check to see, actually I'm going to start with x plus 3. I'm going to check and see if x plus 3 is a factor. Here's all my coefficients. 2, 7, negative 4, negative 27, negative 18. Bring down my 2. Negative 3 times 2 is negative 6. 7 plus negative 6 is 1. 1 times negative 3 is negative 3. Add those together, I get negative 7. Multiply, I get 21. Add those, I get negative 6. Multiply those, I get 18. Add them together, I get 0. Okay? I'm just going to recap right there, because this now tells me 3 things. If I were to plug in negative 3 into that fourth degree polynomial, I get 0. That means x equal negative 3 is a 0. X plus 3 is a factor. Okay? Now, I want to check another one. But because that one worked and I got a remainder of 0, don't start over. Work with the answer. It reduced the whole thing because I got a remainder of 0. It reduced the whole thing from 5 terms down to 4. So now I'm going to check 2, right? But just start from there. If negative 3 didn't work, then I had to go back and start over. But it did. So I'm just going to start from right here. Bring down your 2, 4, 5. 2 times 5 is 10. Add those together, you get 3, 6, and you get 0. Okay? Again, that tells me It's a 0, right? That's x equals 2. It's a 0. And, whoops, easy there. Now, this gets really big, okay? Because remember, in terms of finding zeros, things get nice and simple once we have a quadratic. We've got one. 2 rounds of synthetic division reduce the power 2 times. So what I have left down here is 2x squared plus 5x plus 3. You have some much more basic factoring methods. This one is easily factorable. Or you could have gone to the quadratic formula with some pretty small numbers. A is 2, B is 5, C is 3. Okay? Once you get that down to a quadratic, you've got those tools back, particularly the quadratic formula. Works out nice. Okay? So now if I go back to f, I could say this from that whole process. If I wanted to write f just as its factors, x plus 3, x minus 2. It has one of 2x plus 3 and x plus 1, right? How do I know that's all of them? It's a 4th degree polynomial, which means it's got 4 factors, right? By the way, up here, if I wanted to find the last 2 zeros, which this is kind of the direction we're headed more in section 4, I could have used these, right? And I could find the last 2 zeros by setting each of those factors equal to 0 and solving, okay, and found all 4, okay? That's a lot. I know that's a lot, but that's all we're going to cover here with long division and synthetic division. Again, we kind of got into what we're going to use it for. That's really more where we're headed in section 4. Big thing here to make sure you're comfortable with: doing long division and doing synthetic division. That's really what you're going to be practicing in section 3.